Bismillahirrahmanirrahim. Assalamualaikum. I'm back. Still in this chapter 2, which is analysis of statistical determinate trusses, which we are now focusing in this video. We are focusing on the next part, which is to identify the zero force member. So, in this video I'm gonna explain about how to identify the zero force member in a truss. Member that have no forces in them is called as a zero force member. So member yang tidak mempunyai sebarang daya, so F is equal to 0, called as a zero force member. So zero force member exists because of the 3 points here. The first one is due to the stability. It may increase the stability of the truss. The second one is as a support. So it can provide the support if the load change. And the third one for the aesthetical. It may added for the aesthetical reason. Aesthetical ni maksudnya dari segi cantik, nak bagi nampak cantik, so they add that member, even though it will react as a zero force member. So zero force member exists because of these 3 points, which is the first one is stability, the second one is will react as a support if the load change, and the third one is for the aesthetical. How are we going to determine the zero force member? So the analysis is simplified if one can identify those member that support no loads. Zero force member can be identified quickly through inspection. Macam mana nak buat tu inspection macam mana? So zero force member can be identified if these 2 points you should know. So the first one is if 2 member form a truss joint and there is no external load or supportation at that joint, and those member will become a zero force member. Bila mana 2 member membentuk truss joint di hujungnya, dan there is tiada external load ataupun reaction dekat joint, so maka 2 member ini menjadi zero force member. That is the first point. The second condition is when there are 3 members form a truss joint which 2 are collinear and there is no external load and separation. The same condition as with the first condition, which is no external load and support condition at that joint. So the force in non-collinear bar will become a zero force member. So we will look how to differentiate this member in the truss. So the first one is here. 2 member form a truss joint. 2 member form a truss joint where there is no external load or separation, di mana tiada external load dan juga reaction. So kita check dekat truss ni, we check on this truss where joint there are 2 member in joint, which is joint there is no external load and no separation. So C we have external load, B we have a support, F we have a support. So this condition is fulfilled at point D, which is 2 member, and this joint don't have any external load and separation. And also at point A, 2 member. So at point A there is no external load and also support reaction. So this and this will become a zero force member. Okay, so this will become a zero force member, and also this one also zero force member. Okay, so this, the FDE also will become a zero force member, and also FDC will become a zero force member. Okay, so member DE, CD, AF, and also AB will become a zero member. Okay, and you can easily prove these results by applying the equation of equilibrium at joint D and joint A. So you guys boleh kira, kalau try buat summation of Fx equal to 0, you guys akan dapat this two member will give a zero force, and also if you did a equation of equilibrium at joint A, also will give you the value is equal to 0. Okay. Okay, zero force member can be removed as shown in this figure when we analyze the truss. So after kita eliminate the zero force member here, zero force member, so the truss will become simplified, and we can analyze by using this truss. Okay. So next is for the second condition, which is when are three members. Okay, bila mana ada three members form a truss joint, which two are collinear, and there is no external load and separation at the joint, and the force in the non-collinear bar is 0. Okay, collinear ni maksudnya selari. Okay, maksudnya dia kata dua member, when are two member is collinear, so this point, so this and this is a collinear. Okay, collinear. So this will be, this is collinear and this collinear. So this member, this is member D and A, will represent a zero force member, which is the non-collinear bar. Okay. And the same condition with the at joint C. So we have member DC here. So DC and also BC. So this is a collinear. Okay. So at joint C, this is the non-collinear bar or member will become a zero force member. So this will become a 0. So this also become a zero force member. Okay. So after we remove the zero force member, so we can analyze by using this truss. Okay, and please note that the zero force member are used to increase the stability and rigidity of the truss and to support for the various different loading conditions, as I mentioned in the early in this video. The zero force member exist because of the stability, also as a support if we are having different in loading, and also for aesthetical part. Okay, so that's all for the zero force member. So so you guys can determine how to classify whether the member become a zero force member or not by using these two conditions. Which is when two members form a truss joint and no external load and separation, and those member become a zero force member. And the second one is when there are three members form a truss joint and there are collinear, and there is no external load and separation at the joint, and the force in the non-collinear bar will become a zero force member. Alright, so I guess that's all for the zero force member. Maybe I will give some examples in the next video. Alright, okay, hope you guys can understand about how to determine the zero force member in this video. Alright, okay, Assalamualaikum, thank you.